Two identical glasses of water, but one is slightly heavier. The reason? It's not sugar at all. The real culprit is sneakier. Heavier forms of hydrogen, hiding in plain sight. In this video, you'll learn what isotopes are, how scientists write them, and how the weighted average of all isotopes gives each element its official atomic mass. Let's start with the basics. Every atom is built from positively charged protons, neutral neutrons, and tiny electrons. Protons decide the element, change those, and you change the element itself. However, neutrons can vary. Hydrogen's most common form, protium, has 1 proton, 0 neutrons. Deuterium adds 1 neutron. Tritium packs in 2 and is radioactive. In fact, nearly every hydrogen atom you meet is protium, about 99.98%. Deuterium is rare, while tritium is even rarer. Because a sample is a mix of isotopes, scientists list a single average mass on the periodic table. They multiply each isotope's mass by its abundance and add the results, a weighted average. We just met protium, deuterium, and tritium, and saw how abundance turns their masses into one average. Curious how much you're remembering? Your personalized practice test, flashcard set, and study guide are all waiting for you. Just tap the link now and keep watching. Future you will thank you. Now, let's picture this. Think of isotopes like different types of apples. They're all still apples. Just like isotopes are all the same element, but their masses vary. One's light, one's medium, one's heavy. When we ask for the average mass of apples, we must consider how common each type is. Ever wonder why atomic masses have decimals? It's because they're not from one isotope. They're weighted averages. For chlorine, some atoms weigh 35 units, others 37. But since chlorine 35 is more common, the average mass ends up at 35.45. Here's a real example. For carbon, 98.9% weighs exactly 12 atomic mass units, and 1.1% weighs 13. Crunch the numbers, and you land on 12.011 atomic mass units, the value printed on every periodic table. To recap, isotopes share protons but differ in neutrons. Nature sorts them by abundance. And a simple weighted average turns that mix into the atomic mass you see on the table. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet, content made just for you.